We're interested in this division, which we can see done here, but in this case we're only going to be interested in the remainder. So can we find the remainder without having to do all of the division? If we consider this example with numbers, 14 divided by 3 is equal to 4 with a remainder of 2. We know that we can write 14 as equal to 3 times 4 add 2, where 3 is the divider, 4 is the quotient, 2 is the remainder. If we consider the algebraic division we did, and we called the original expression here f of x, then f of x must be equal to x minus 5, since that takes the position of the 3, times this expression here, which takes the place of the 4, add the remainder, which takes the place of the 2. So this is another way of writing this. If we evaluate f of 5, then we get 5 minus 5 times this expression with the 5 substituted in. Add the 78. But we haven't substituted in here because we can see immediately that this will become 0, so it doesn't matter about the contents of this bracket, because 0 times anything is 0, so we just get left with 78. So in order to work out the remainder, without doing all of the division, we can just evaluate f of 5. And this is the remainder theorem. As a second example, consider this division, which we can see done here, giving us a remainder of minus 6.5. Considering numbers again, if we had 17 divided by 5, we know this is 3 with a remainder of 2. So 17 may be written as 5 times 3 add 2. 5 comes from here, the 3 is the quotient, and the 2 is the remainder. We want to write this in a similar way. We'll call this f of x, and it's the same as the 17. This is the divisor, so is in the same position as the 5. This is the quotient, so takes up the same position as the 3. And finally, we have the remainder, and tidying this expression, we get 2x plus 1 times the x squared plus 4x plus a half, take away 6.5. We could evaluate this directly without doing the division by evaluating f of minus a half. If we substitute in, we get 2 times minus a half plus 1. This is minus 1, add 1, which is 0. So we'd get 0 times the bracket. Of course, we should have substituted minus a half in, but since it's multiplied by 0, it won't matter. Take away the 6.5, which is minus 6.5. And once again, this is the remainder theorem. We can find the remainder without doing the division.